Good morning, viewers. This is Kasturi Day. Today, I'm going to start with a discussion of Newton's first law of motion, that is also called law of motion. Okay? So, before I start, I will request you to please do subscribe my channel if you have not subscribed yet, and please do ring the notification bell because as soon as a new video is uploaded, it will notify you. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from this video. And also do meditate before you start your day. So before I begin, we will start with a short meditation for just 1 minute, and then we will start with the discussion. Okay. So for meditation, please do concentrate on a point of light. Light to getting blessings of God, getting enthusiastic, things which you are doing, for joining this meditation. Start with the first law of motion. What is the law state? What this law states? It states that body continues to be in the state of rest or of uniform motion or in uniform motion in a straight line unless an external force is applied to it. So what does it state? Law of inertia or law of motion. First law of motion states that when a body is moving or when it is in the state of rest, okay, when it is moving in uniform motion or it is in the state of rest, it will be in that state, whether it's in the rest state or in the motion state, it will be in that state unless an external force is applied on it. Yes, when an external force is applied, then only that rest body, the state of rest, can change into state of motion, or in the state of motion, the body which was in the state of motion can increase its speed or its decrease its speed and can stop. So this is the first law of motion. So what are the examples? So objects in motion stay in motion and objects at rest stay at rest unless an outside force, which is known as unbalanced force, acts on it. Okay. A stationary object with no outside force will not move. Okay. Without applying any force, a stationary object will not move. With no outside force, a moving object will not stop. Okay. Whenever a body is moving, if you don't apply any force, then it will not stop. So when a car brakes quickly, what happens? The passenger will be thrown forward. This is because of inertia, the tendency to remain unchanged, tries to keep the passenger moving. Okay. So what happens when a moving car just applies a brake? Suddenly it applies brake. So what happens at that time? The passenger tends to fall in front, thrown forward. Because what happens when it stops the car, when the car's brakes are applied, the car stops. At that time, what happens? The base of the car that has stopped, so So the lower portion of the body has stopped. Okay. And but the upper portion of the body that is still moving with the movement of the car. So what happens when the lower portion has stopped, the upper portion is still moving, it will move forward because the car was moving forward. So it has a tendency to move forward, fall forward, fall in front. Okay. So this is the law of example of the first law of motion. Another example is there. An object will remain at rest unless an active and unbalanced force is applied to it. Okay, and an object is in motion will continue with constant speed and direction unless it is acted on by an unbalanced force. Okay, so this is the Newton's first law. Okay, so the ball is the object. The ball is at rest. When unless and otherwise the ball is kicked, the ball will remain in that place. Okay? And if the ball is in motion and it's moving in a particular direction and in a particular speed, unless an a force is there to stop the ball, okay, force is applied to change its direction, the ball will move in that direction with the same speed. Okay. The next slide is the property of a body, that is inertia. Okay, so the property of the body, inherent property to remain at rest or to remain in motion with the constant velocity is called inertia. So what is meant by inertia? We are calling it law of inertia. So what is inertia? It's the property of the body. It's the inherent property which is inside the body. That's the property, original property of the body to remain at rest or to remain in motion with a constant velocity. That is known as inertia. Okay? The Newton's first law is often called the law of inertia. Why? Because it is known that some objects have more inertia than others. So it is obviously more difficult to change the motion of large boulders than that of a basketball. What happens? Why it is known as law of inertia? Because certain objects they have more inertia than the other objects. So it is obviously more difficult to change the motion of a large boulder. When there's a large boulder moving, it's very difficult to stop or change the direction of the large boulder's motion and than a basketball. Basketball is small and it's less heavier than the boulder. Boulder is much more heavier. So uh, that to change the motion of the basketball or change the direction of the basketball is quite easier than changing the motion or direction of the large boulder, because it has the large boulder has more inertia than the basketball. Okay. The inertia of an object is measured by its mass. Okay. How is the inertia measured? The inertia of an object is measured by its mass. The greater is the mass, the greater is the inertia of the body. The more heavier the body is, the more it has its inertia. Mass can be determined by measuring how difficult an object is to accelerate. Okay, so mass can be determined by knowing, if we know that how the object accelerates, or rather how difficult an object is to accelerate. If a body is heavier, then it will accelerate. We will have to give more energy to accelerate it, to increase its speed. But a small ball that requires a less energy to accelerate it, to increase its speed. So therefore, the mass can be determined by measuring how difficult an object is to accelerate. The more the mass of an object has, the harder it is to accelerate. There are two conditions on which the first law of motion is dependent. Two conditions. What? Object at rest and objects in motion. Okay. So first is at rest and second is in motion. So when an object is at rest, then the velocity is zero. Initial velocity is zero, and acceleration is also zero. It is because it is in the rest position. Therefore, the objects continue to be at rest, right? Then object in motion. When the object is in motion, the velocity is also is not equal to zero, and neither the acceleration is equal to zero. The velocity is not equal to zero, but acceleration is equal to zero because the object is in motion. Okay? Therefore, the object will continue to be motion with constant velocity because its velocity is constant and in the same direction. Excuse me. Object will continue to be in motion and constant velocity and in the same direction. When there is a constant velocity, there will be acceleration will be equal to zero. So second condition is when the object is in motion and velocity is not equal to zero and acceleration is equal to zero. That means it has constant velocity and in the same direction. It's not changing its direction. Okay, therefore the acceleration becomes equal to zero. Now the external force is defined as we know that in the law of motion definition, there was an external force is applied when to change the state of the rest, also change the state of motion. So what is that external force defined as? It is defined as the change in the mechanical energy, that is either the kinetic energy or the potential energy in an object which is caused by external agents. So it's a mechanical energy or rather force which is uh, uh, it's a mechanical energy that may be kinetic energy or potential energy which is applied in an object. Okay, object which is caused by some external agent. Externally, this energy is applied on the body. Okay, either it may be kinetic energy or potential energy which is applied externally by external agents. It is applied. That is known as external force. For example, external forces are friction, normal force, or air resistance. These all are external forces. Okay. Now, inertia are of three types. One is inertia of rest, inertia of motion, and inertia of direction. Okay. Now, what is inertia of rest? The property of a body to oppose any change in its state of rest is known as inertia of rest. It is the inherent property. You know that inertia means inherent property of the body. Now, this inertia of rest means it is the inherent property of the body which does not allow to change its state of rest. Which does not allow, or rather which opposes to change the state of the rest of the, to change the state of rest of the object. Okay? So that is the inertia of rest. For example, when a bus or train starts suddenly, when the driver starts suddenly a bus or a train. So what happens? The passengers who are standing in there, they will tend to fall backward. Why? Because what happens when the bus or train starts, when the vehicle starts, what happens? The vehicle starts in motion, comes in motion. So what happens? The lower part of the body, the lower part of the body of the person who was standing, that also starts moving. Okay? But the upper part of the body that remains at rest. So the upper part, as the body lower part moves forward, the upper part will fall backward because the upper part is still at rest due to its property of inertia of rest. Okay, that's why the passenger falls backward. Clear? Next is the carpet is beaten with a stick to remove the dust particles. The carpet comes in motion, but the dust particles remains at rest and due to inertia. And that's why they fall down and thus get separated from it. So what happens when a carpet, when we want to dust the carpet, no, we remove the dirt from the carpet. So what we do, we beat with a stick. So what happens? The carpet is at rest. Okay? So when we are beating the carpet starts moving, but the dust particles, when the carpet was rest, the dust particles were at rest. But when we are beating the carpet is moving, but the dust particles are still at rest due to its property of inertia of rest. So what happens? The carpet starts moving, but the dust particles which were at rest, they start falling down. Thus, they get separated from the carpet. Next, we come to inertia of motion. Okay? So, inertia of motion means it is also the inherent property of a body which opposes any change in its state of uniform motion. Okay? When the body is moving, then what happens? It's the property of the body that will oppose any force, any change that opposes its motion, that want to stop its motion. So that is the inherent property of the body, and that is known as inertia of motion. Clear? Now the passenger fall forward when a fast-moving bus stops suddenly, as when the driver of the bus applies brakes suddenly, the lower part of the body comes to rest. It applies its brakes, the vehicle stops. The lower part of the body stops, but the upper part is still moving. Because the bus was moving, suddenly it has stopped. The lower part is stopped, but the upper part is still moving. It moved forward. You will tend to fall forward. Now, a luggage is usually tied with a rope on the roof of the bus. Why? It is because, as sometimes when the bus stops suddenly, so that time what happens? The roof of the bus that will stop, but the luggage was still in motion, so it may fall off the bus roof of the bus. That's why it's advised to tie up the luggage with a rope. Next, we come to another third inertia, that is inertia of direction. That is, it's the property of the body to oppose any change in its direction of motion. Okay, so it is the property of the body, inherent property of the body, which does not allow any change in the direction of the motion. It is going due north, it will tend to go north unless and otherwise external force is applied on it. So it has a tendency to move northward only. When the force is applied, it will oppose the force and it will not try not to move its direction from the direction of north. So that property is known as inertia of direction. For example, when a bus driver negotiates a curve, that is, it's moving like this, like it is moving a curve like this. In the picture, you can see on the road, the passenger falls towards the center of the curved road. Okay? Whenever the driver is negotiating of the passenger's experience of force, which is acting away from the center of the curve. Force will act away from the center of the curve. Okay, and therefore, what happens to this tendency? It will move, the passengers continue to move in a straight line. But as it is moving in there like this, the passenger will try to fall away from the center of the curve. It will fall. So if it is moving like this, the passenger will not fall inside the curve, but it will try to move away from the curve, because it has a tendency to move straight like this. It was moving, the car was moving, so it has a tendency to move like this. That's why the passenger may fall. If he falls from the car, then he will fall like this, in this direction. Now, a stone tied to a string is whirled in a horizontal direction. If the string breaks, the stone flies away tangentially. The picture, you can see the girl who is moving whirling the string in this way with the stone tied at the end. Okay, and if this string breaks, then the stone will go straight tangentially without moving in circle, because it has a tendency to move straight, not in a curved direction. But as it is moving here, so it will uh, if it breaks, then it will fly off in a straight direction, which will be tangent to the circle. Okay. So this is inertia of, the law of inertia. Okay. So in my next video, I will move on to inertia of, sorry, so second law of motion. Okay, Newton's second law of motion. So till then, please do go through this. If you have any doubts, please do write in the comment box. If you are a new viewer to my channel, please to subscribe my channel and ringing the notification bell. And also, please to meditate if you start when you start your day. Okay, so this much for today. Thank you for joining and have a good day.